The first type of examples that we're going to have a look at with regards to maximum and minimum is two-dimensional examples. So basically flat areas and perimeters and what have you. So nothing with volume and surface area just yet. Okay, but it'll give you a good understanding of how we actually apply this theory and have fun. It's a cool. It's a cool section. So I think you're going to enjoy this. Okay. We have got a rectangular den for pigs that is enclosed by 400 meters of fencing and makes use of one existing boundary wall. Okay, so let's just show you the little diagram we have over here. So we've got a little enclosure that we've created by using 400 meters of fencing. So do you agree that this highlighted yellow part is the 400 meters of fencing that we've used? The back wall is the one side of the enclosure that they said we used, okay? Now, okay, so we need to take note of that. It says calculate the dimensions. When they use the word dimensions, we're looking for your length times your breadth, okay? The dimensions, so that the area will be a maximum. Okay, right, so let's see how we're going to go about doing this. What do I know right away? Okay, the only thing I really know right away is that these three yellow sides added up give me 400 meters. Okay, so we're going to have to start by giving ourselves some variables to work with here. I'm going to call the short sides of my enclosure x, and obviously both those, it's a rectangular shape, so both of those sides will have to be x. I'm then going to have to give this longer side a different variable, so I'm going to call that y. Okay, you can call it whatever you like, but I'm going to stick to kind of the standard x's and y's. Okay, so based on me giving them those variables, then I could say that 2x plus y is equal to 400 meters. Okay, now they've given you this information for a very specific reason, okay? And the reason why you need to use this formula here is because you need to get rid of one of the variables, okay? You can't actually go any further into working out the area of the enclosure until we get rid of either the x or the y, okay? Now, I think it probably is going to be easiest to get rid of the y, and the reason is because, well, it's nice and easy to isolate it. Let's get it on its own, okay? If I were to get y on its own, I would do it by saying 400 minus 2x, okay? So can you see now what I've done? So instead of having a y, I'm going to take y and I'm going to replace it. I'm going to take it away and I'm going to replace it with 400 minus 2x. Okay, and can you see now we're not dealing with a problem of having two different variables anymore. Now we're just working in terms of x. So now it should be pretty straightforward from here. Okay, right, the question wanted to know the maximum area. So the next thing we're going to have to do is put together a formula that represents the area of this shape. Well, area of a rectangular prism, rectangular shape, pretty straightforward. It's our length times our breadth. Our length being this 400, take away 2x, and the breadth being just x, okay? So therefore, if I just simplify this, if I say area equals, if I distribute, all I'm doing here is I'm distributing my x. So 400x minus 2x squared, that's the formula for the area. And now we have to calculate the dimensions so that we maximize the area. What do we actually mean by that? Let's just take a second to go back to the diagram. What do we mean by maximizing the area? Well, really the idea here would be, what if we made the two lengths of x a little bit shorter, but we extended the length? That would create a different rectangular shape. Or what if we shortened the middle length, but we extended the two sides? That would also give us a different shape. So each one of them obviously giving you a different area, okay? So that's the idea, is that we're looking for which one is going to give you the maximum area. So 2x squared. So what we need to do here is we need to calculate the derivative of the area. Okay, why? Because to find the minimum or the maximum, we let the derivative equal 0. So I'm going to find the derivative of my area, and I'm going to let that derivative in terms of x equal 0. Okay, that is what you have to do. That's the key here. So derivative of my area is going to be 400 minus 4x, and I'm letting it equal 0. I'm then going to, I'm going to bring my 4x over, so I'm going to make it positive 4x. I'm going to divide both sides by 4, and I'm landing up with 100 being equal to x. What is that giving me then? So what is this length going to have to be? It's going to have to be 100. What is this going to have to be over here? That's also going to be 100. This over here will be 400 minus 2 times what x, which we've now said is 100. 400 minus 200, which is giving you 200. So what we've calculated is that for us to keep the breadths of my rectangle at 100 meters and the length between them 200 meters, we're going to maximize the area inside that enclosure for our pigs. And just be careful that when you are answering this kind of question, that you answer the final question. They wanted the dimensions, so the length we said would be 200 meters, and the breadth we said would be 100 meters. Okay, so just make sure you obviously finish it off by answering the question that was actually asked. So fundamentally, what was the most important thing to remember here? Once you had worked out your area formula, derivative equals 0 is what's going to help you find the maximum. Okay, lots more examples to do, so make sure we watch all those videos. Well done.